Hello, my name is Raquel Medina and I will present to you a new Earth modeling feature in DSG 10ep.5.4. This new Earth modeling feature is called resistivity modeling. The resistivity modeling workflow is condensed into an easy-to-use package accessible from the DSG Tools menu. The streamlined workflow allows users to create 3D distributions of resistivity using different methods, QC the results, and export them as a regular 3D grid, which is suitable for use in resistivity imaging inversion software such as Sperry's Roxy Blast. In this new functionality, the user can generate a catalog of UDAR images representing possible structural, stratigraphic, and fluid distributions scenarios. The comparison of the real-time UDAR measurements with the catalog images can alert the operations geologists of changes around the borehole. This additional understanding of the subsurface can help make real-time decisions regarding steering the well. I will now demonstrate to you the new resistivity modeling tool in Decision Space Design's 10ep.5.4 Earth Modeling module. The new resistivity modeling tool can be accessed from the DSG Tools menu. It can also be accessed by typing resistivity modeling in the quick access bar. The resistivity modeling workflow is condensed into these three tabs in the resistivity modeling tool. As you can see here, by selecting a few inputs, the user can use their well location where they have the control well logs, such as resistivity or porosity, permeability, and phases, and the planned well locations where the user can also investigate the resistivity response over this section of the planned well. Here the selections are made to choose a 3D stratigraphic grid, such as the one shown in the image with two intervals, and the well list with the logs and the phases or lithotype log, porosity, permeability, and resistivity log. Saving and generating input will create a point set similar to the one shown, where you have a representation of the log measurements at the resolution of the 3D grid that is used for the model. Once the user has set their input parameters, then they go to the modeling parameters tab, where they can choose different modeling options such as constant, resistivity log, or no resistivity log for each of the phases that they see in the phases log. The resistivity modeling allows you to select the resistivity log from the control well as the input for the distribution in the areas nearby the well or far away from the well where we plan to drill a new location. We also have an option to input a scalar in the panel, where this scalar is going to basically multiply the horizontal resistivity by a value that will define the vertical resistivity for an anisotropic effect. The other options are constant, where you can set a constant for the resistivity in a specific phases, or you can choose the no resistivity log option, where you can select the parameters, the physical parameters to be used in the arch equation if you want to distribute the resistivity based on the position of the oil-water contact using a different configuration for each interval, and the input will be the porosity and permeability distribution. So you have to choose that as input in your input section, input selection section. Once you have selected all the input parameters in the modeling parameters tab, you can also distribute the resistivity with different conditions regarding the oil water contact position. Per interval, you can enter a position for the oil water contact and set the value of the resistivity without the oil water contact to the number close to the water resistivity as expected. Once you have all your definitions made, then you can enter the names of the properties that you want to use for your 3D distribution and press the Save and Run button. This will either override the system distributions or it will generate new if they are not calculated previously. Once your distributions are populated in the grid, you will get this image that the estimation is complete. And then you can go into your QC section where you can visualize in DSG, in the different editors, the distribution in the 3D, in section view, or even in map view. And also you can use the ERIC modeling tools for data analysis to further QC your results. So once you are happy with your QC of the results, which you can also display in the Cube Editor in this section, you're ready to move on to the export step where you can configure your sugar cube grid and the resolution of it and the properties that you want to sample onto it for further analysis once you export to the Roxy Blast application. Going to the Export tab in the Resistivity Modeling tool, you can choose your well list, the plan well where you want to create your regular 3D grid from, and the vertical range for your resistivity model. Since we have oil water contact at 3000, I can set it to 3020, and that will include the oil water contact portion and some of the portion below where we set the resistivity to a very low resistivity like water formation. Once you define your model of your resistivity, sugar cube grid name, and the different X, Y, and Z resolutions, you can choose whatever many properties you want to sample into that, and you can have multiple realizations of your resistivity distribution based on the different methods into the same stratigraphic grid. Once you choose that, then you can click Export, and this will generate the sugar cube grid for the properties that you selected. There's also an option to export as a 3D curtain. This is a JSON format that can be imported in different applications, and those are user-defined applications. These are not provided by one. Once the extraction is complete into the sugar cube grid, it will automatically display in your 3D editor. In essence, the sugar cube grid is a cutout of the stratigraphic grid created with the regular sampling that basically describes the same properties of the section of the grid that was used along the well path of the well plan. This can be QC in 3D or in the 2D section as well. So you can see the perfect match between the original grid that was used and the sugar cube grid. Once you have that, you can go to the File and option in DSG. In the menu, you can choose Import Export, and you can go into the Export 3D grid option and use different the different formats that you have there to create the export file. You choose a path and then you select the properties that you want to export. And basically you can do for all the data or certain intervals of interest. And in the case of your properties, you can select the properties and change the target name for the property as assigned. So you can now proceed to export your sugarcane grid, and that concludes the demo for today. Thank you.